Hey guys, okay, so over the next few days we will be making a couple of videos for regarding the CBSE topics for science and maths. Now these videos are meant for people who don't particularly listen in class, and I urge you all to not use this as your study material. Just use this as your reference material for the exams. By the way, this is for the third term only. Hey guys, okay, so today we'll be going over carbon and its compounds. Now, have you ever wondered why carbon? Why not say sulfur? Why not phosphorus? Why not lithium? Well, it's because of carbon having a unique property called tetravalency. It means that it has 4 valence electrons and can combine with 4 other carbon atoms to form molecules or other compounds. Now, generally these compounds are much more stronger due to the fact that carbon has a small atom. Now, next it has another property called catenation. This means that it can form bonds with other atoms of carbon, and these compounds formed are usually long chained. Alright, now let's go over some properties of carbon compounds. First of all, they're poor conductors of electricity. A good example of this is diamond. Now it's not a very good conductor of electricity, is it? Next, compounds have low boiling points or melting points. Hence, we can understand that the force of attraction is less between the molecules. Next, how about we go into some examples of carbon compounds? Well, they're divided into 2, unsaturated and saturated. Saturated mostly include alkenes. Their general formulas are CnH2n+2. Oh yeah, guys, please forgive the poor handwriting. I know, it's very horrible. Next, we go into alkenes. These are part of unsaturated compounds. Their general formula is CnH2n. And then finally, alkynes. Alkynes have CnH2n-2. So you can see the similarity between each group. It's quite once you think about it, it's not really all that hard to learn. Now let's go into some examples of alkanes. Now all 3 of these groups have common prefixes met, eth, prop, bute, pent and hex. Now alkanes, what do you think it'll be? Methane, ethane, propane. Next we move on to alkenes. Now remember, alkenes, it has ene. So you just bring that as a suffix to the word. Like for example, instead of meth, we have methane or ethene or propene. And now similarly for alkynes. Now alkynes, they have yne at the end. So just add it to the prefix. So what will you get? Methine, ethine, propine, etc, etc, etc. Next we go on to the type of bonds found in alkanes, alkenes and alkynes. Now alkanes, they're single bond. That basically means this little dash. Alkenes are double bond. That's this. And no, it's not equal to sign. Believe me, it's not. Then alkynes, that is a simple triple bond. It's like this and like this. Next we move on to the products found in alkanes, alkenes and alkynes. One is methane. Now methane, it has 1 carbon atom, and so it has how many hydrogen atoms? 4. See, remember this, H2n+2. Next we move on to alkenes. Now alkenes, they don't have methane. They start with ethene. So basically it'll be C2H4. And similarly for alkynes also, you don't have methane, you have ethine. That's the first that comes in the list. So it would be C2H2. We do. Now how about we go into the formula for this, the structural formula. Hold on, let me just quickly erase all of this. Magic. Alright, anyways, getting back to topic. Let's go with the structural formula. Actually, no, wait, let's go with the molecular formula first. As I already mentioned earlier, for methane, you have CH4, right? So, what do you think the structural formula will be? A very simple C with H, single bond, actually, not H, my bad. E, that's a horrible line. Okay. Yeah. H, and H. Alright, so now as you guys can see, there's a single bond over here. This particular thing is called a single bond. So are these, and these. Alright, so how about we go on to the structural formula for, say, ethene. So that is a C2H4. So this means it has four hydrogen atoms and 2 carbon atoms. So it would go something like this: C double bond C and H, 2H, H2, sorry, 1 H over here, 1 H over here. However, this is not exactly the formula. It should go a little something like this. There you go. Little something like this. Alright. Now how about we go into ethyne? Let me just quickly rub this out. Alright, so now how about we go into ethyne? Ethyne is a simple C2H2. Now this basically means like this. Since ethynes have a triple bond, it's C triple bond C and H and H. Alright, next we'll move on to the electron dot structure for each of these examples I've given you. First we start with a simple CH4. What is this? Methane. Methane. Okay, sorry about the way I just talked. Alright, so now it goes like this: C in the center, a dot to represent the electrons, dot and dot. Now it's surrounded by 4 hydrogen atoms, and to differentiate between the hydrogen electrons, I will just show an X. It makes things easier to understand. Go like this and like this. Alright, now the dot structure will only be complete once you actually show this. This particular part is quite important. It completes the octet. Thank you. So the electron structure, electron dot structure for methane. Now next we go on to ethene. That is a simple C2H2. Alright, so as I mentioned earlier, ethene, all alkenes in fact, they have double bonds. Alright, now as you remember, the structural formula for ethene was H like this, C double bond C and H again like this. So basically this electron dot structure will be even more easier to make. C, go like this. Now there are 2 ways to do this. Either you can go with the electron over here and here, or you can go with the electron over here and here. Now generally I prefer the bottom one. I don't know why, don't ask me questions. Next we can go with the second carbon atom, that's C again, and this time to differentiate we shall simply put an X for the electron, and you have an X down here and an X down here. Now this particular part is called the double bond. And finally we have H, the hydrogen atom, the the almighty hydrogen. Alright, now okay, since we have already used a dot and an X, we can go for a circle or we can go for a different color. Now I am going for a different color because I can and I have the ability to, but you guys will have to go for, say, a circle, or maybe, I don't know, say anything you guys want. Go ahead. And now, as I said earlier, the electron's dot structure will only be complete only if you draw the circle, not the circle of life, just the circle. It's like this and like this, and finally, now these two these 4 electrons are both part of both the carbon atoms. So basically it would go a little something like this and a little something like this. Yeah, there you go. See? Now how simple was that? This looks really weird, I know. It looks like a bunch of potatoes. I'm sorry again in advance. Next we go into ethine. Now since we don't have enough of time for for me to explain ethine, I'm just going to quickly skim through it, you can say. Alright guys, so ethine is a simple C2H2, and over here add a Y and E. Now over here this electron dot structure will be CCC. CCC represents electrons, by the way. And now you have another C atom, electrons. This is the triple bond, and then you go like so. My bad, sorry. You go for the H and H. Alright, so since I don't have enough of symbols at my disposal, you guys can be creative again. Just be creative. Just don't draw something like a question mark or something like this. That's just weird. Don't ever do that, please. Alright, so you can go for a different color or a different symbol like a circle. And now, as I said for the past 2 times, an electron dot structure is only complete with a circle. And this and this. Alright, now over here the basic idea is that this particular carbon atom is taking all 6 of these, 3 which are its own and 3 which are from the other atoms. So over here they're technically sharing the atoms. It's not just stealing, it's not snatching it, or it's not doing anything, it's just sharing the electrons. So that's it with saturated and unsaturated compounds. Guys, next we'll go on to isomerism, and for this we'll be using the example of butane. Butane is a simple C4H8 9 10. Yes, thank you, 10. Awesome, I'm awesome. Alright, so just quickly rub this out. Alright, and so the structure will go a little something like this: C H H. Now remember, this is butane, ANE, so it has only single bonds. If it was butene or butine, it would have a double bond or a triple bond, and that only one in the center, or around the center, not exactly in the center. And yeah, H H and H. Alright, this particular formula is called an isomer of butane. Now if you were to say remove the H, the hydrogen, you would be left with a skeleton structure of butane. That's CCCC. Yay. So basically C4 over here is butane. This is called the skeleton structure. Now from this you can actually construct you can actually not construct, but you can make the other isomer of butane. However, it's not exactly like this. So basically that is taking this particular part and bringing it here. You'll see what I mean in a minute. Alright, so as I said earlier, you should take that C atom over there, bring it like this, H, H, and H, accompanied by H, 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 and H. Now over here there was if you remember, there was an H, there was a hydrogen atom, right? So that basically we bring it over here. So you have an isobutane. Sorry, I forgot. Alright guys, so anything that has C and H in it, like only C and H, that's alkanes, alkenes, and alkynes, you can call them as hydrocarbons. That's hydro and carbons. And the main difference between this and carbon compounds is, say you have CO2. Now technically this is not a hydrocarbon. This cannot be a hydrocarbon. However, you have say C2H2. This is a hydrocarbon. Alright? So next we'll move on to functional groups. So what are functional groups? They are basically groups that can replace H and C in a carbon compound. Later on next year, maybe next year you'll be learning about organic compounds, which is the same thing. So anyways, now functional groups can even replace just hydrogen, like for example Cl or Br. Now technically these two, they are called halogens. Alright, and if you were to say write a compound with the structural formula that included this, it would go a little something like chloro with the compound name. Next, alright, so I'll give you a very quick table on this. So firstly you have chloro, that's Cl. Next, this is called halogen, by the way, or Br. Then after that you have alcohols, that's what alcohols? OH. That's OH. Then after that you have aldehydes. Aldehydes go a little something like CH with a double bond O. And next you have ketone. Oh, sorry, I did not mean to write the name. Ketones go a little something like C, and this space over here, this is for say carbon atom or anything, basically wherever it's attached into the group. Whatever comes after it or before it comes inside, it comes in the space. And single bond O. And finally carboxylic acids, that's simple C double bond OH. Oh, sorry, not double bond, single bond OH and double bond O. And afterwards, if you guys want, you can even take note of this. It's ester. That's a C with single bond O and a double bond O as well, both. Alright, so now that we're done with functional groups, let's move on to some properties of carbon compounds. Like for instance, you have addition reaction or combustion or substitution reaction. First we go with combustion. Now you guys should already know what combustion is. I mean, it's just lighting stuff on fire, but here we need to explain it a little bit. So what is combustion really? burning of a substance in the presence of oxygen, or simply O2. When you burn this, heat, actually fire, sorry, should be fire over there, but whatever. When you burn this, you should get CO2 plus like heat accompanied by light, and yeah, I think so. So yeah, that's it. It's pretty simple, it's easy to explain also. Next we have oxidation. Now oxygen is basically addition of oxidation is basically addition of oxygen, so that's basically addition of O2. Now in the textbook, yes, I'm going to give you a textbook example. You have C3 single bond CH2OH, and this will give you CH3 COOH in the presence of like an alkane or alkaline, in the presence of an alkaline like KMNO3. Alright, next we go on to addition reaction. Now what is addition reaction? It is basically addition of hydrogen atom to an unsaturated compound in the presence of a catalyst. Over here we'll go for a very simple formula: C R R R and R. By the way, this is another textbook example only. And in the presence of nickel and hydrogen, you will get C single bond C single bond R single bond R single bond R and single bond R with single bond H and single bond H. Now basically what R is over here is say CH2 or CH3, no, not CH3, sorry, maybe, yeah, CH2 or CH3, like that. That's what R represents, but you guys don't need to learn that, don't worry about it. Alright, next we go for substitution reaction. Now generally you can say alkanes or saturated hydrocarbons, they are not exactly reactive to most reagents. However, in the presence of sunlight, a saturated hydrocarbon gets a Cl instead of H, i.e. it gets a chlorine atom instead of a hydrogen atom. It just replaces it, substitutes. So you have CH4 plus Cl2 in the presence of sunlight, you will get CH3Cl plus HC. Alright, so now that we are done with the properties of carbon compounds, why not we go for ethanol or ethanoic acid? Actually, they both are different, but yeah, I mean, we're going for both of them. So for instance, you have ethanol, which is basically alcohol, and yes, it literally is alcohol, the stuff people drink to get drunk. However, it's not in its pure form over there, it's actually dilute, because if you were to consume pure ethanol, you would probably die. Yeah, that's it. So how about we go for some properties of ethanol. Now you have, first one is reaction with sodium, and here's a very simple equation for it: 2Na, that's sodium, plus 2CH3CH2OH. Now this is a functional group, alcohol. This particular part is alcohol. Remember I told you OH alcohol. Alright, and like I said, it replaces over here an H with an OH. Now this will give you 2CH3CH2ONA. Now remember, H over here, it gets replaced with Na. That's it. It's all plus H2, of course. So you get this plus hydrogen gas. And by the way, this particular equation, this whole thing is a balanced equation for this particular reaction. Next we move on to reaction of ethanol at 440 degree Kelvin with excess concentrated sulfuric acid. You will probably get an unsaturated compounds like, okay, we'll go according to the equation, CH3 CH2 OH with concentrated H2SO4, that's sulfuric acid, will give rise to CH2 double bond CH2 plus H2O. And over here you can see that sulfuric acid, it acts as a dehydrating reagent. Alright guys, so next we will go to the next next compound, that is ethanoic acid. And basically this has a functional group carboxylic acid, due to which it is considered a weak acid. Actually, not considered, it is a weak acid. Now firstly we can go with the reaction between it and absolute ethanol in the presence of a catalyst. Now in the presence of a catalyst, this particular reaction will give you an ester. And as you recall earlier, esters are basically C single bond O double bond O. That's it. Alright, so yes, now I shall give you the equation for this, that is CH2COOH, this is ethanoic acid, plus CH3CH2OH, and this is ethanol. In the presence of an acid, it'll give you CH3CO double bond O CH2 CH3. This particular part will sorry, not this 3 is an ester. Alright, now say you want to get the alcohol of this, that's ethanol. You have to treat this particular reaction, actually sorry, the product with sodium hydroxide, which will give you the alcohol plus the sodium salt of the carboxylic acid. And this particular reaction is called saponification. Alright, perfect. Next we move on to reaction with base. Basically ethanoic acid, when reacting with a base like say NaOH, alright, you will get sodium ethanoate. Alright, and finally reaction with carbonates and hydrocarbons, it gives the salt plus CO2 plus H2. That's carbon dioxide plus hydrogen, and it'll go according a little like this: COH, and this, remember, ethanoic acid plus sodium carbonate will give you 2CH3COO plus water plus carbon dioxide. Alright, and now we have one last topic to cover, that is soap, and actually more like water and stuff, but whatever. Anyways, next we have micelles. That's actually part of soap now. Micelles, it's basically it's actually a little bit complex. It goes a little something like this, like this, then like this, multiple times, many. All right, now each one of these is a C17H35 compound, each one of these, and it is attached to a sodium ion. Right guys, now we'll go for soap. Now you guys have all used soap, I hope. Just kidding, I know you guys use soap. Alright, so have you ever thought, what is the molecule? How does a molecule of soap look like? Well, it goes a little something like this, something like this, with sodium ion at the top. Yay, something like this. Sorry, this is over here. Alright, and now this is one molecule of soap. How soap works is basically this one molecule accompanied by maybe like 10-15 more. They all surround, like they just go around like this. They surround each dirt molecule or each dirt spot. That's like all the dirt is encompassed, you can say, or enclosed inside this. Alright, and this whole thing all together forms a micelles. I hope I pronounced that right. It's MICELLES. Alright, and now as I was saying, this is one molecule of soap. Now this particular part is a hydrophilic end. See the philic, and this particular part, actually sorry, not this entire part is a hydrophobic end. Phobic. Now basically what this means is loving, and this means basically scared. It's scared of water. It prefers not to go towards water. Alright, and yeah, that's about it for micelles. And next we'll go on to hardness of water. Sorry guys, I forgot to mention that this particular thing, sorry, let me just draw this properly. This particular part is called sodium stearate, sodium stearate, and its formula is C17H35, so it's CnH2n plus 1 Na. Oh no, sorry, COO twice Na. Yes, that's it. Sodium stearate. For those of you interested in what a soap molecule is, it is a sodium or potassium salt of a long chain carboxylic acid, and the long chain carboxylic acid is basically stearic acid. Alright, This, by the way, I just read from the textbook. Alright, moving on. Well, now we'll move on to hardness of water. Now, this is basically caused by the salts of calcium and magnesium mixed inside the water. So, it's a very simple way of removing this is by mixing a detergent into it. Now, what are detergents? Well, basically they are ammonium or sulfonate salts of long chains of carboxylic acids. Now, if you remember, soap is potassium or sodium salts of long chain carboxylic acids. However, detergents are ammonium or sulfonate salts of long chain carboxylic acid. And basically this detergent, it does not form insoluble precipitate or scum, if you will, in hard water. And as you know, hard water is formed due to the addition of salts of calcium or magnesium. And a quick use of detergent is it's used in shampoos, soaps, and for cleaning, and in cleaning products for clothes. So anyway, and with this we are done with the chapter. Now, if you were listening, you should have understood why have we picked carbon. What's the speciality of it? Then what are saturated and unsaturated compounds? Then what are functional groups? Then what else? The different properties of carbon compounds like addition reaction, substitution reaction, and all that. And then you have two important compounds of carbon compounds. That's ethanol and ethanoic acid. And finally, soap and detergents, along with hardness of water. Thank you all for watching.